Okay, so today's lecture is what is data visualization and why you should do it. It corresponds to chapter 1 in the Tomorrow Munzner textbook. So we can start out with a couple of definitions. And Munzner says computer-based visualization systems provide visual representations of data sets designed to help people carry out tasks more effectively. Competing author Ware says visualization applies vision research to practical problems of data analysis in the same way engineering applies physics to practical problems. And it's interesting to note in the Munzner textbook, visualization is often abbreviated as viz. So you may hear that term from time to time in these lectures. And again, Ware writes a competing text, and that one's entitled Perception for Design, and it's from Morgan Kaufman Publishers. And in case you're interested in experiencing or exploring more about the field. So Munzner starts out each one of her chapters with something called the big picture. And it's usually given in the form of a bounding box. And visualization is suitable when there's a need to augment our human capabilities rather than replace people in the computational decision-making method. So this is somewhat different from machine learning, where we're replacing the human. We have the human as part of this decision-making process, but we're breaking down the information so that it's possible for the human to zoom in on the portion of the data that they want to visualize and make a decision on. And the design space for possible visualization idioms is huge. There are many different ways to go about things, and there should be considerations for both how to create and how to interact with the visual representations. And these are, as you might expect, full of trade-offs. Most possibilities in the design space are ineffective, so finding one that's actually effective is important, but then validating the effectiveness of that design is also needs to be done, and that can be quite difficult and impossible in some cases. So in terms of the big picture, visualization designers need to take into account three different types of resource limitations. One, computers. How much computational power do you have to display things? There may be less on your desktop versus a cyber canoe wall. Humans, and then the displays themselves. So what are the limitations of the resolution of the displays? How many displays do you have? Looking at something on your phone is going to be quite different than, again, looking at a cyber canoe wall or a cave-type immersion experience. And visualization usage can be defined in terms of why the user needs it, what data is shown, and how the idiom is designed. So why do we use visualization? Well, it's appropriate when your goals are to augment human capabilities and when analysis of problems are ill-specified. So if you don't have a complete specification of the problem and it's not something you can do necessarily algorithmically in a foolproof manner, then visualization is fairly appropriate. It allows people to offload internal cognition and memory usage to their perceptual system. And as you know, human vision is a high bandwidth channel in our brains. We process visual information in parallel, so we see many different things at once. Whereas sound is processed sequentially, and you can understand that if you listen to a song from beginning to end. You don't listen to the entire song all at once, although there are some things where people have taken old Ramones albums and played all the songs at one time so that you get a cacophony of noise and can clear out a record in 3 minutes or less. But that's not tremendously effective. Other senses, touch only conveys a limited amount of information, and there aren't really good methods for smell or taste yet, although people are definitely working on that, in terms of immersive reality environments. So if the problem has well-defined questions to ask about the data, then you can use purely computational approaches such as statistics or machine learning. Computers are obviously important to have in loops since it's important to draw all these visuals, since it's difficult to draw all these visualizations by hand, particularly if they update frequently with size. And again, in terms of the last two, if you find a good way to taste the data, definitely let me know. I think there's a research paper, maybe even a PhD dissertation in there. So why not just use pure statistics? statistics? Well, take a look at these four sets of statistics. These are known as Anscombe's quartet. And the four data sets have exactly the same summary statistics. That is, their mean, their variance, and their correlation are all the same. But when we plot these, we get very, very different plots. The data are distributed in very different manner. So you can see that the distribution of X first data set, is nicely correlated with that regression line. The third one, it's pretty well correlated with regression line, but there's an outlier, and the second and the fourth, produce some real problems with using any type of regression analysis, primarily due to the clustering in the fourth and the nonlinear function in the second. So, idioms is a distinct approach to creating and manipulating a visual representation. There are a whole heck of a lot of different ways to create a visual encoding of data as a single picture. And the design space of possibilities gets even bigger when you consider how you want to manipulate one or more of these pictures or visual representations with interaction from the user. And talking about resource limitations, display capacity is certainly a limitation. It's easy to design to show a small amount of data cleanly, but when you have a large amount of data, it's harder to design. Computational capacity, certainly computer time and memory are limited resources. During the pandemic, it's been increasingly difficult to get graphics cards, and graphics take a lot of resources. And then, last but not least, cognitive capabilities. There's only so much memory and attention that we can pay to things. There's also change blindness, which people don't see major things that are happening in the background. And I have a couple examples that I'll play for you during the actual lecture. And in terms of creating visualizations, it's generally not a useful goal to optimize. That is, find the very best choice. A more appropriate goal is to satisfy. That is, to find a good solution. And it's also good to consider multiple alternatives rather than fixating on a single solution. And last but not least, the textbook uses a three-part analysis framework. So first ask, why is the task being performed? What data is shown in the views? And then last, how is the visualization idiom constructed? So Munzner goes about this as a what, why, and how idiom, or process for the analysis of the visualization. Thanks so much for watching.